Welcome back. This is the same night. This is back to back. I just did the previous video if you watched that. So let's do another math question. So we see here that let f is a linear function. F is a linear function for which f, so the result in which when the input to f is 6, subtracted the result for which the input of f is 2, this is equivalent to 12. It's equivalent to 12. Okay, and then the question is, what is f when the input is 12 minus f when the input is 2? So again, let's take a second to inhale the question. Okay, f is a linear function, and when this minus this, it's 12, and they're asking for this. Now right away, you can see a few probable tendencies with the problem. First of all, they're not asking for a specific number. They're not asking for a plus b plus c or d times e divided by 2. They're asking for the result of an expression. So when it's like this, sometimes if you're able to just factor, even if all of these are hidden, but if you somehow got an equation with this and then you equated it to something, then you're done. But in this case, it's functions, and functions, we don't even know what the function is, so that's going to be pretty hard. But we do have a clue on what the function is. It said it's a linear function. So that means there's no exponential relationships between the numbers in the function. And yeah, that's pretty much what you can tell from the question. Now, what does it mean there's no exponential relationships? Well, if we take something like x squared, you probably think you already know this, but let me explain it through first principles and you might be surprised. If we have x squared, now usually let's say we have x, and let's say we throw 3 in here. X is the amount of apples. We throw 3 apples. Okay, so this is equals to 3. Very easy. Okay, let's say there's some relation where it's apples squared, which means apples times the amount, apples multiplied by apples, which means apples added to itself the total amount of how many apples there are. So let's say apples was 3, this would just be 3, or even 2x, it would just be 6. But this thing is self-dependent in a way. This is like a whole equation in and of itself. I don't know, this is if you got stronger, then you got more confident, so you got stronger, it's like a revolving pattern. It's like this thing, if it's a diagram. So plotted on so basically that means it increases exponentially. But I like to think of it in this way because math is just an expression of some concepts, and this is the concept that exponent is trying to express. Okay, anyways, it's a linear function, and we've learned that this means that there's none of this. So all the coefficients to the degrees of x is 0. So there's just none. So we can write this. Let's say f of an input is equals to ax plus b. Now let's see what this means. Actually, what this means. So there's no degrees, so we got that correct. There is one here, Yeah, there is a degree, but it's not exponential, so it's okay. It's still a linear function. But the input to a linear function could still be multiplied by a constant. We never said that was not the case. And we never said there was more constants. There was not more constants to the equation other than the constant multiplied by x. Now, b could be any arbitrary value. It could be 15 times 2 times 31 times... This could all be represented as b, and same with a. It could be like 3x plus 17x.
我这个给你照张相，你铺的时候，那个特不好，这个尖这么高，这个尖这么低，这么能。
我怕是hard. So a is also any arbitrary sum. So it might not be this simple, but it also is this simple. Okay, so we have this equation mapped out in a more concrete way. It's still very abstract, but at least we have the blueprint. So now we could do something. So f of 6, that means now we don't know a and b. We don't know the constants. Usually if you know the input, you know the output, but this time you don't know the process. So let's just write the process in an abstract way. F2 is 2a plus b. Okay, so now we're finding the process instead of finding the output or the input. Okay, so we know that this is equivalent to this is equivalent to this. So essentially 6a plus b minus brackets, you have to, because it's the whole thing, this. And we see that b's cancel out, so a equals 3. Now they asked us what f12 is minus f2. And when doing this little substitution, we realized, although we only have one, like usually when you have two variables, you need two relations to know what the values of the two variables are. This time we only had one relation, but we realized that because it's in this form, the constants are going to cancel out, because that's the nature of the constant. They're singled out, they're lonely. Okay, so this is also going to cancel out. So essentially this is just 12a minus 2a, because the b is always going to cancel out. Then equals whatever. And we know this is equals to 10a, and we know a is equals to 3. So we know this equals 10 times 3, which is 30. And there we speeded to the answer. F12 minus F2 equals 30. And note that we didn't even solve the equation. We're still like blurry on this equation. But because they asked us this very specific question, we kind of like streamlined our way to the answer without knowing even the environment, which is cool.